Hello everyone, welcome to Vishal Robotics AI. If you want to learn robotics, artificial intelligence, ROS2, computer vision, Python or C++, but you don't know where to start, then this video is for you. Robotics can look confusing in the beginning because it combines many things at the same time. You need programming, sensors, cameras, motors, Linux, ROS, AI models and real hardware control. But if you learn everything in the correct order, robotics becomes much easier. In this video, I will explain a clear roadmap that you can follow to start from basic programming and slowly move towards a real robotics and AI projects. This channel is focusing on practical learning. Here we will learn Python, C++, ROS2, computer vision, artificial intelligence, and robotics by building real projects step by step. The goal of this channel is not only to explain theory, the goal is to understand how these technologies are actually used in real system. We will start from beginner level programming and later move forward towards advanced projects such as robot control, camera-based perception, object detection, gesture recognition, AI assistant, and robot-based and ROS-based robotic systems. So if you are a beginner, a student, or a developer who wants to enter robotics and AI, then this channel will help you to follow a practical path. So first, why robotics needs multiple skills? Before starting the roadmap, you need to understand one important thing. Robotics is not only programming, it's a combination of software, hardware, sensors, control, perception, and intelligence. A robot needs software to process information. It needs sensors to understand the environment. It needs algorithm to make decision. It needs control system to move or act in the real world. For example, imagine you want to build a robot that can detect a person and move towards them. For that, you may need a Python or C++ for a programming. You may need OpenCV or an AI model for camera-based detection. You may need ROS2 so that different parts of the robot can communicate. You may need Linux because most robotics tools run on Ubuntu. Finally, you need robot control logic to move robots safely. That is why robotics should be learned step by step. If you directly start with the complex robot projects, it can become frustrating, but if you build the foundation correctly, every advanced topic becomes easier. So step one here is to learn Python. Python is a beginner friendly, easy to read and widely used in robotics, artificial intelligence, machine learning, automation and computer vision. As a beginner, you should first learn the basic building blocks of Python. You should understand variables, data types, strings, numbers, conditions, loops, list, dictionaries, functions, classes, modules, and file handling. But do not learn Python only by memorizing syntax. Try to connect every concept with a real example. For example, a Python list can store sensor values, a function can process camera data, a class can represent a robot, a loop can continuously read from a sensor or a camera, a dictionary can store robot configuration values. This type of learning is much more useful than only writing simple examples that are not connected to real application. On this channel, we will learn Python in this practical way. We will start from basics, but we will connect the examples to robotics, AI, and computer vision. Now, the step 2 is learn Linux basics. After Python, the next important skill is Linux. Most robotic systems use Linux, especially Ubuntu. ROS2 is also a commonly developed and deployed on Ubuntu systems. You do not need to become a Linux expert at the beginning, but you should understand the basics. You should know how to use the terminal, how to navigate folders, how to create and delete files, how to copy and move files, how to install packages, how to run Python scripts, and how to use permissions. So Linux is not optional for robotics, it is the part of the foundation. We will learn Linux commands in a simple and practical way, especially the commands that are useful for Python, C++, ROS2, and robotics development. Then step 3 is learn C++. After Python and Linux, we will learn the most important skill, which is C++. C++ is widely used in robotics because it is fast, efficient, and suitable for performance critical systems. Many robot drivers, control systems, navigation systems, and ROS packages are written in C++. As a beginner, you should not try to learn every advanced C++ topic at once. Instead, focus first on the C++ concepts required for robotics and ROS2. You should learn variables, data types, conditions, loops, functions, arrays, vectors, classes, object, references, and many more for basic project structure. The goal is not to become an advanced C++ developer immediately. The first goal is to understand the enough C++ to read and write basic robotics programs and ROS2 nodes. A good strategy is to use Python for fast prototyping and learning, then use C++ when performance and low-level control are important. Then the next major step is ROS2, which means Robot Operating System 2. ROS2 is not exactly an operating system like a Windows or Ubuntu. It is a robotics framework that helps different software components of a robot to communicate with each other. For example, one node can read camera data, another node can process the camera data, then another node can detect objects, another node can control robot movement, and then another node can handle speech or AI responses. ROS2 allows these different parts to communicate using topics, services, actions, parameters, and launch files. As a beginner, you should learn what a ROS2 workspace is, what a package, nodes, topics, publishers and subscribers, what messages are, services, actions, parameters, and how the launch files work. You should also learn basic ROS2 commands such as ROS2 node list, topic echo, topic info, ROS2 run, ROS2 launch, and ROS2 parameter list. Once you understand these basics, you can start building real robotic system. ROS2 is one of the most important skill for modern robotics deployment. Then we will move to the next step 5, which is ROS2 basics. After ROS2 basics, you should learn computer vision. Computer vision allows a robot to understand visual information from cameras. For a beginner, OpenCV is a good starting point. You should learn how to read images, display images, read webcam video, process frames, convert color spaces, detect colors, find edges, detect contours, detect faces, track hands, and perform pose detection. Computer vision becomes more powerful when you combine it with ROS2. For example, a camera node can publish image data, a computer vision node can process that image data, another node that can use the detection results to control the robot or trigger an action. This is how real robotic perception systems are built. So computer vision is not just about image processing. In robotics, it becomes the robot visual perception system. After Python, Linux, C++, ROS2, and computer vision, you can start learning artificial intelligence and machine learning. AI can help robots detect objects, understand speech, recognize gesture, estimate human pose, generate responses, classify emotions, make decisions, and interact more naturally with humans. At the beginning, you do not need to start with very complex mathematics or advanced deep learning. First, understand basic concepts such as what a model is, what a training means, what inference means, what a data is, labels, accuracy means, and how to use a pre-trained model. Then you can slowly move towards tools and models such as PyTorch, TensorFlow, YOLO, MediaPipe, speech recognition models, language models, vision models, and many more. For robotics, the most important point is not only a training a model, the important point is how to integrate the model into a working robotic system. That is why we will learn AI in a practical way, connected with cameras, speech, ROS2, and robot behavior. The most important part of this roadmap is a project building. Do not wait until you become a perfect in Python, C++, ROS2, computer vision or AI. Start building small projects early. You can start with Python projects such as a sensor data simulator, a webcam viewer, a face detection system, hand tracking projects, simple ROS2 publisher and subscriber, keyboard controlled robot simulation, a ROS2 camera node, or an object detection pipeline. Later, you can build more advanced projects such as voice control robot, a gesture control robot, a robot dashboard, and AI assistant connected with the ROS2 or a humanoid robot interaction system. Robotics is learned by building, testing, failing, debugging, and improving. Every project will teach you something that theory alone cannot teach. On this channel, we will follow this roadmap step by step. First, we will learn Python. Then we will learn Linux commands. After that, we will learn C++ for robotics. Then we will move to ROS2. After ROS2, we will learn OpenCV and computer vision. Then we will add AI and machine learning. Finally, we will combine everything into real robotics projects. Later, we will work on advanced systems such as robot perception, speech integration, AI assistants, human-robot experiments, and complete ROS2-based robotics pipeline. The aim is to move from simple code to intelligent robot. So this is why the complete roadmap to start learning robotics programming. If you are just starting, do not try to learn everything at once. Start with Python, then Linux, then C++, then ROS2, then computer vision, then AI, and finally combine everything into projects. In this next video, we will begin with the Python and understand why Python is important for robotics and AI. Subscribe to Vishal Robotics AI if you want to learn robotics, AI, ROS2, Python, C++, and computer vision through practical projects. Thanks for watching, and I will see you in the next video.